Okay, test. Test.
Was it dead? Oh, it's not dead. Mine died like for an hour.
If there are no lights, there is no lights.
Watching.
You need to have a list, right? Create a list. Okay.
Jack.
Better.
I don't want to come across as so militant. It's a company
Doesn't matter.
but I don't think people work with. Yep.
You. We are live.
Okay, that's going to be crazy.
Okay.
I don't check this. It's yeah. Yep. So they're watching already.
Yeah.
Yeah. So I'll just talk a bit first. No, wait for these guys to come in. So don't be shy, please. So there's people online already watching, so I'm just going to start talking, otherwise they're going to be quite bored and wondering what's going on. So firstly, thank you very much for coming. I know at the moment it's particularly difficult, and I know for a lot of people, they just really rather not do it. I also know on the other side that people would like to do real meetups again. After like millions and millions of hours of Teams and Zoom calls, it just gets a bit much. So something real. Two things from me. Number one, this place you see right now with the AV equipment, you can always have a meetup here. I can arrange it. If you want IoT related talks, I can arrange that you can talk to people. It's fine. Please come. There's no charge. I would like to see more people here. On that point, I have a front-end project starting, which in the current economic climate is quite interesting, probably. If anyone is looking for work or has been let go and has some front-end knowledge, let me know as soon as possible, because I can get you in quite high quite quickly. Maybe not. However, we're not doing front-end tonight. We're doing embedded and real IoT, I like to think. So we have Thiago and Claudio. They are members of our embedded team. They can introduce themselves much better. I'll just say that these are the two guys, or at least this was the team that did Drive Now Munich. So if you have any questions about Drive Now, these guys could probably answer. However, I will move on to Thiago, and I would just say that if you want to talk to me after, if you want to have me on LinkedIn, the link's actually in the bottom of the description. Feel free. I'm here until quite late afterwards. I hope to talk to you all. And yeah, let's get going. So Thiago, please.
Okay, guys. Again, thank you very much for joining us in our, I guess, our first full embedded meetup. I will talk a bit about DDS, the Data Distribution Service. First of all, my name is Thiago Duarte. I'm also a consultant here at Constant Reply. Constant Reply is an accelerator IoT company. We have the department responsible for the back end, front end, and we guys from the embedded responsible to dig in the hardware and make the things connected over the world. About my background, I have 11 years of experience. First of all, I'm from Brazil. I have 10 years of experience in embedded software development, mostly in aerospace industry with rocket launchers and aircrafts. And then 1 year ago, decided to join to this wonderful world of IoT and to make our life full of things connected. So this is my agenda. I will talk a bit about the concept of DDS, about how this protocol works, what are the benefits, the difference between the major protocols in the IoT industry, and a bit about the features that makes this protocol so interesting, especially when we think about high transfer speed, transferring data with high speed and with reliability. So we have an interesting, I recommend you guys to visit our website. We have an interesting article about the popular IoT protocols, the architecture of them, and also the benefits comparing with each other. When we're thinking about the MQTT, is one of the most used protocol, we have the MQTT broker that connects the things, even if you're using Mosquito or AWS or other service. It's necessary to know where is your broker and how to connect to them. And the broker will take care of the publishing, subscribing, will define all the rules of the communication. When we think about AMQP, we have the same. We have some difference with MQTT, but we have, if you see, the same concept. We have a publisher, we have a subscriber, and we have some element in the middle controlling the communication. Here, I use an example of the RabbitMQ. When we talk about Kafka, it's a bit more complex, but in the end, we can create an abstraction that we have just one element, that's the Kafka cluster, that will take care about connecting things. When we compare all those three major protocols, we see that we have one similar element, that is the broker. That's the guy that will guide the communication, establish the rules, as I already mentioned. We have a lot of advantages when we have a broker. we have just one place to take care about who talks with who. And also we have one guy that we define, for example, to store the data. For example, when we think about Think Shadow, this guy can make sure that when you send some data to the cloud, or when the broker receives the data, it can store and then forward this message as soon as the other device connects to the network. So there are a lot of benefits. But when we think about on the other hand, we have some issues related to latency. We have just one single point of failure. This is quite critical when we think about safety critical systems. And not always, it's good to say not always, it's not scalable, because if you connect maybe thousands of devices with just one broker, depends, of course, of your architecture, we would have some delays that for the processing of the message in the broker side. So imagine a situation that we have, for example, in a premises, we have in industrial IoT, we need that two devices has to share data, for example, with states of machine or position of some cards or some comments from the operators. If you have a broker in the middle, and for example, in terms of sensor, we have a high speed data being transferred, for example, for a sensor, we would lose some time doing the transfer of the data due to the broker in the middle. So why not provide the direct communications? For that, some guys, they joined in 2001 and they proposed one standard, one middle, one API that would present one machine-to-machine communication without a broker. So the device will connect to each other directly. They also consider the architecture as the same that we have in the other protocols based on the publisher and subscribers, as I mentioned, with low latency and scalable. So that's the way that DDS was born. What's the just short review? I know that maybe it's common knowledge and when you talk about protocols, is the concept of multicast, because it's important to understand how DDS works, especially during the power up of the system, where the things identify each other in a network. The multicast is a concept that I send messages. I don't specify exactly who we receive, but I specify the group that we receive the message. It's interesting because it makes the things like we don't need an IP. We don't need to know all the elements in the network. It's also comparable with the broadcast. That's like I'm sending a message to everybody. With multicast, I can notify a group of guys that of device that we receive the data, and those guys will also receive here in the source, the address of the things that is sending the message. How the DDS is implemented? It's implemented first of all based on the concept of the discovery, as the word is quite clear, but it's the step of the DDS where the things, when are connecting the same network, they identify the presence of each other. And how it's done? Based on the send of the announcement. So all the guys that are in the same network, that are in the same group, multicast group, will receive an announcement from the device, say, hey guys, I'm joined the network, let's talk with each other, and then share which data each one can share, and which data that you guys expect to receive from me. Maybe I can provide you, publish to you some meaningful data. After sending the announcement, all the things that are connecting the same network, they share, first of all, the topic name, because this is DDS works based on the definition of the topic. That's like a kind of tunnel that the data will be sent. We can have, for example, the same data being published in two different topics. So it's important to establish the communication that the topics are the same. They share also the data format, because maybe to prevent serialization issues, the elements saying, hey, this is the format of the data that I expected. This is the format of the data that I can provide. So in each one of the things, they do the comparison and provide the subscription match. That's, okay, we are talking the same topics, you expect data in the same topic, and with the same data format. Other interesting feature is the QS, because we can define the behavior of the data. The guys can share, for example, hey, I expected one data that is periodic, or I expected some data that is reliable. And during the discover, they share also, because if there is some mismatch in terms of QS configuration, the middle by itself will prevent that this communication of those guys will not happen. And then each one of the peers have to match all the three requirements. They know, okay, for example, we have one machine can say, okay, I would like to receive the sensor data from this thing. So when the sensor transmits a data, this machine will receive or receive comments from an operator. After that, all the system, all the elements network knows from where the data will come, and also when published, they will publish it to the guys that we expect to receive the data. This protocol, it was specified in such a way that will provide some services without any, we don't need to write code for that. For example, in terms of the keep alive, so in the background, all the things will be sharing some metadata to identify, okay, this guy that I'm transmitting data is still alive. If he, for example, stops sending the keep alive or the heartbeat, in other words, it will be sent, the transmission to that specific things will be stopped. And in case, for example, that this thing is transmitting data from one specific element, in case of keep alive is missing, it will be trigger callback to the application, say, okay, that guy that you expect to receive some important data is not present anymore. So can provide some ways that the things can manage it, trigger fault, or maybe select another source. Other important things that the DDS also provide is the serialization. This is when we think about a lot of computers and hardware connected together, we have to always consider the engines, because we have also PowerPC architectures, we have PC architectures that they can be talking in different engines, and usually we have to take care of this on the application side to provide, to know, okay, I expect to receive data from that guy. Yeah, that guy is a PowerPC and running an x86 platform, and I have to provide to swap off the bytes. And DDS provide this for free. So when applications receive on the application level, when the data is received, it's already serialized for the engines where the application is running. Other thing that is in terms of the connection, you in application side, you don't need to take care of to establish connection, TCP, UDP, and etc. The API provide this service by itself, and also the reconnection. As I mentioned, if case of, for example, keep alive is missing, the application for some reason stopped working, when it's connect again, the discovery will provide the reconnection among the things. So here, one example that I consider like a service-oriented architecture. We have three elements in the network, consider an industrial IoT environment. We have, for example, a user interface where the operator can start or stop some operation in the machine. We have the machine itself, on the other hand, expecting receiving machine status, publishing machine status, and also providing comments. And for example, considering that we have a temperature sensor that would also be published to the user interface. For example, if the machine reaches 100 Celsius degrees, the operator would be able, or automatically or manually, to stop because maybe there is something wrong with the machine. So this architecture provides a nice framework that we can connect the things, which one provide its own service. So again, the background services that is provided by the DDS, not necessary to be implemented on the application side. So this is comparing with the first picture that I present about the interaction model of DDS, of MQTT, AMQP, and also Kafka. That's the interaction model of DDS. We have also the concept of publisher subscriber. There is another abstraction at the top that would call data writer, data reader. That is really the element that will be transmitting and receiving the data during serialization. And we have also the concept of topic, that the tunnel that the data will be transferred. So now the question is, where is it used and why? I got this information from the DDS Foundation, and also have some experience in 7 years ago working with DDS. It's use it a lot in safe critical systems, especially when we think about aviation. A lot of projects, a lot of aircrafts that are connecting the hardwares in high-speed network using DDS. DDS became some years ago part of the FACE concept. FACE is a approach defined by the Department of Defense in the USA, that they establish kind of standards to develop the system that they bought, for example, from Lockheed or for other military companies, in such a way that we can, in case, for example, an update of the system, you know the interfaces because already defined using DDS, and you just replace the elements. You don't need to redesign the system completely, just partially. And it's also used in the medical devices. They are, I guess this is from the example from Philips. It's a system that also using DDS to collect data. I also saw some projects that use DDS to share data in hospital, especially to understand where are the things, the status of the things. It's also used in the energy industry. For example, these wind mills we're using to share the status of the system using EDS, and also in power plants. And it's also, there are a lot of efforts in the last years of using EDS in industrial IoT, because it fits for the purpose, especially when you think about the premises. We don't want to sometimes we don't want to share our data, for example, to a broker that's out of our premises. And considering the latency, it's good if you can connect the things directly. So I will use here just one example that I got from the OpenDDS that is a pretty simple example that shows how can we, just a second, that we can connect show how the things are done automatically. Sorry. Okay, I'll show it. Small. So here we have two examples. This guy, they are very just demonstration application that it shows that we can publish something here on this application, and in the other side, without any previous configuration to say, okay, this is running the local machine. I could be connected, for example, in the other computer, and this guy will be subscribing the data that is being transmitted on the other side. And somehow it fails. But I mean, there is no previous configuration or previous IP or destination configuration from any one of the applications. It's done quite automatically using the multicast and the communication or Discover running in background. When I'm talking about one of the features of DDS is the concept of domain, because as I mentioned, the applications will discover itself automatically when they are connecting the same network. But consider, for example, one factory. Sometimes you would like to segregate the system. For example, you can have two product lines separated. This is what I tried to show here. And we don't want, for example, that the sensor for one product line send the data to another one. The concept of domain, it's defined as a integer. We can say, for example, that the system on the left side is running on the domain number 1, and on the right side, the system is running on domain number 2, in such a way that the data that those guys on the right side will not establish the communication with the other side. And we can also define, for example, a common domain that we can, for example, in this case, the central management will receive from the both sides and consolidate the data and provide, for example, for the operator, the data from the both, and then the controlling of the data. So, and here just an explanation that how it's defined the common domain that we can have, for example, application A, application C segregated, and they don't share data each other and don't disturb the communication. The domain is defined when you start the application just by integer value, 0, 1, until 255. You can define, for example, that's the word of my application, and that's the word of my other application, and they don't want to share the data. So here, just saying that one idea that we can present, we have 3 domains. Domain 0 will be where we will join all the the two product lines, and the domain 1 and domain 2 will be segregating the things. Now, other important feature of DDS is the concept of QS, or quality of service. The DDS provides us a way to tune the communication and define how the data will behave. For example, if you have a sensor, we expect that the data will be transmitted periodically. If you have a comment, we expect the data to be transmitted once as the operator press the button. But we expect that this data is reliable. When the operator press, okay, I want to stop now the machine because there is an error, because it's time to stop, we expect that this data will be delivered. In case of a failure on the transmission, we expect that this data will be transmitted again and received and acknowledged on the subscriber side. There are a lot of features and a lot of characteristics of the communication that we can tune, but we can summarize them in 4: the real-time delivery, the bandwidth, the redundancy, and the persistence. When we talk about real-time delivery, it's like, okay, I have a data that has some frequency. I would like to share with all the elements of the system that's the frequency of the data. And in case of the data, for example, we have a deadline missing, the DDS allows the application to receive some notification, say, okay, the data that we expect to receive in 100 milliseconds, we received it 1 second ago. So you can provide some ways that the subscriber can take some action, for example. Especially in safety critical system, it's good because we can, with this notification, we can, for example, change the source or trigger an error or stop an operation. This is related to the deadline of the data. Other characteristic that you can define is reliability. DDS by default doesn't provide an acknowledgement when the data is received. But in case you have something that's very important and you expect to receive an acknowledgement from the publisher, from the subscriber, you can define the QS saying, okay, this data is important to be delivered, and I would like to know if it doesn't happen. The lifespan is in a way that looks like the TTL that you have in the TCP/IP, that you define, okay, we expect that this data, with the DDS put a timestamp in the message, in the data sample, say, okay, this data was received now, and the time to leave of this message is like 1 second. Out of 1 second, this sample is considered invalid. We can also tune, especially for low footprint applications, something related to the resources of the system, and that's why we have some options in the resource limits. You can define, for example, stacks of the TCP tasks, and also DDS also has he creates some tasks related, especially when you talk about the reliable data, that it's a task correlated database. You can tune to say, okay, this is important, but I would like to establish some limits because probably I will run out of memory. Bandwidth, we can, for example, if you have a system that using a SIM card or 3G, 4G, we can establish, for example, okay, I would like to reduce the bandwidth, especially in terms of the discovery. That's something that is always happening, to don't run out of our data package. Or because maybe you have a very low network, and then low speed network, and you would like to not create a kind of chaos and block the communication. So you can define what is the bandwidth, limit bandwidth of the system. We can define also, this is also important for safe critical system, is the idea of redundancy. We can have, for example, 2 sensors providing the same, for example, 2 temperature sensors providing information to operator, but in the end, we would like to receive just one. The other one is just in case of failure. You can define here how the system would behave. For example, when both systems transmitted the messages, which one will win? And the subscriber, which sample from which source of the subscriber will receive the data. So it also can be defined and use the QS. And also the persistence. It's interesting because we don't know how the data would behave. For example, we initialize a machine and like a computer that controls the operation of the machine, and the machine starts a little bit later, but the user would like to press the button to start. But in user point of view, he doesn't know when the machine is really ready to receive the command. With the persistence, you can define, okay, the operator will press the button, the command will not be sent because the machine is not ready yet. But as soon as the machine enters the network and finish the discover, the application, the middleware will take care, okay, this data is important to the machine to start the operation. So you don't need to do it on application side. This mechanism is provided by the middleware. So I will show here some options that we have in one application. This is also one example provided by RTI. That's one of the companies that develop that provide. Just a second. So here I will show you another example that we can, for example, define the liveness of the data. This is we have here some QoS configuration, especially durability, where we can, for example, say that the data is volatile, if it's transient, if it's persistent, as I mentioned in the persistence. In terms of the liveness, if you expect that the middleware will take care by itself by the liveness, or this will be done in application side manually or by the participant. Also, this application provides some examples of QoS that you can dig in the source code. This company provides a kind of built-in XML that you can take care, and you can look and modify and see what is the best for your application. And this is actually a good application to use when you are studying the protocol. The other one for an OpenDDS is also nice, but I had some problems, as you could see, to run the application. So now I will talk, first of all, how we define. As I mentioned, during the discover, the applications share also the data format. But how we define it and how the middleware knows the format of the data. All the implementation of DDS is defined also by the standard. They define that, first of all, we have to define the data before actually we create the architecture of the system, because it's from the data you know, for example, how many elements you have in your network, and who will provide which element will provide the service and that data, that sample to other things in the network. For that, the DDS establishes a file called with distinction IDL that has the similar syntax of the structures in C, C++, with some annotations that we can include some different data types. For example, here in case we can define array of bytes as a sequence of octets with a limit of the data. But in terms of and string as well, we can define, for example, the limit of the string. And we can use a basic variables from C, C++ standard to define long booleans and etc. After take this DLL, the developer now has to generate a code from one tool. It's called IDL Gen, that will generate some code that you build with your application. And this code is already implementing all the things necessary to inform the other applications during the discover the data format, and also the most important, the serialization. It doesn't matter which engine is you are running. This code will provide serialization from both for both words, and big engine and little engine. And then other things that you can't. There are a lot of in the IDL we can also include some annotations. It's like we can change and we can say to the middleware how the data behaves just based on that annotations. We can say, for example, if some data is optional, if some field is optional or not. But I will use one example to share how it works. The key is one of the most important annotation in IDL, because it will help you, for example, to filter the data in subscriber when you receive from multiple samples, from multiple sources. And when you include this on these annotations on the IDL, when you generate the code, it will generate a code that will take care about this behavior that you expect in your system. So here, one example, we can define two sensors. I will reuse one example that I told before. All of them implement a key to identify, for example, the source of the data. On the application side, the QoS is configured to do the filter of that data. But for example, we have sensor 1 as a master and sensor 2 as backup. We can, as soon as we define the key, saying what's the difference between them, and we provide the filtering by the API in the subscriber side. In case of sensor 1 dies, okay, when both send the data, just sensor 1, this computer will receive data just from sensor 1, but as soon as it dies or stops working, the sensor 2 will take care. This data from sensor 2 will be received on the right side, and this without any, no code. You don't need to write this source selection by yourself. It's provided automatically by the API. Now I will talk about a bit which options that we have in the market for the meter. In terms of open source, we have one implementation from Eclipse. It's Eclipse Cyclone. And the other one, I think it's the most famous, is OpenDDS. They provide also some examples and some code on GitHub that you can, for example, contribute with the Eclipse as well. But I think the OpenDDS provides more, in my opinion at least, more tools and more samples. And we have also some community providing solutions and comments and help. In terms of proprietary, RTI is the biggest company in this business. They also provide for a lot of companies. They have a very nice community where you can ask support. You can find examples, and they have a huge documentation. At Linkite, also they have quite good implementation of DDS. All of them are using this standard, but what you can see the difference between them, among them, is actually the support. When we think about the proprietary, you always have to think, if you have a problem, you can write to the support and they will provide you a solution as soon as possible. In the community also, we have also a very interesting open source community that also provides solutions, but in this case you are paying, you can ask to do it faster. On the other hand, we have the problem of the license. When you have, for each element that you install in your system, you have to buy one file, one license that will be for your, imagine that you have 1,000 of devices, you have to buy 1,000 of licenses. So just to finalize my presentation, this is some sources of white papers and some articles in Medium, some guys talking about DDS. Also one book that talks about the industrial IoT and protocols and architectures and the trends. But one of the really recommend is this article that it's kind of survey of the protocols in IoT and also the architecture. Is interesting to see how those guys in the end of 2009, they published this. It's good to see how the industry is moving and the options that you can have now in the market. So, questions?
In the beginning, you mentioned some advantages like scalability and that it doesn't have the same point of failure, but does it have also some disadvantages in regards to like converting to MQTT? Like where would you pick MQTT over?
Mm-hmm. When you think, yes, your question is what are the? I talked about the benefits of DDS and where DDS cannot be good, right? When you think about connect things in different places, for example, I have here one device and I would like to connect at my home. You can do it with DDS, but you have to provide some infrastructure to the things understand that they are in the same network. When you think about MQTT, you have some brokers over internet that can do this, establish the connection. This is one disadvantage, in my opinion. The other thing is in terms of the DDS provides a very interesting way that you connect things like in a distributed way. You don't need to take care into one of them, but maybe you can find some scenarios that you want to know. You want to have one place that will, for example, can log all the communications. In DDS, you can. In the standards define some DDS spy. That is a tool that you can monitor the data that is being shared among the things. But you can have a scenario that, okay, I would like to have this one place that I can, for example, hijack, or I can monitor everything. With DDS, you have some distributed, or you can, for example, have a system that you would like to make sure that the sequence of the data, and it's important for you to have one element in the middle that will provide all those, that will guide the communication. So this is, I see two disadvantages that I can say now. Welcome.
Are there devices that work with the centralized system but not with the DDS? Because as far as I understood it, devices need to be a little bit smarter for DDS because they have to think a lot more. Are there devices that only work with the centralized?
Sorry, I didn't hear you.
Like, with the DDS, the device needs to think about, okay, to whom do I send this information and which information do I want and everything.
Mm-hmm.
And when I have a central instance, devices could, at least in theory, be stupider because they only have to send it out and don't care about anything. So are there devices that work with only a centralized instance but not with a DDS?
I think you can define DDS allows you to define this kind of architecture. I don't know if I'm answering your question correctly. You can. For example, I had one issue once with a device that has some poor performance, and we have to implement, just for one specific data, we have to implement a broker using DDS. In the end, it was, okay, what is the advantage? We are using DDS. But on the other hand, we know that this broker in the middle, we don't need to configure the IP of this, because DDS will take care of the broker. It's possible. DDS is flexible enough to provide this architecture.
What's the underlying protocol that's required for DDS?
The basic TCP/IP stack. By default, DDS use UDP and multicast address to transmit and receive data, but you can, for example, if you have some limitations in your system, or you really want to make sure that the data will be received, you can use TCP. Especially the solution provided by RTI, you can use shared memory to transfer the data, especially when you have, for example, applications running in the same computer. So in Windows and Linux, it's by default, you can select, okay. And you can also define the preferable way, because you can, for example, your application can start transmitting on both, try to establish communication via shared memory and also via network or via TCP/IP. You can also configure it to say, my preferable way is done using shared memory because it's faster, or you can define it using. There are some ways that you can also implement some plugins in DDS that you can, for example, I know some guys that implemented kind of layer to use a serial, especially RS-485, because it's a bus, we can connect a lot of things. Of course, there are some disadvantages because in terms of the discover, as soon as it's happening frequently and it can demand some bandwidth, but in case of limitation, it's also possible to implement. The protocol is quite flexible. It's not really defined that you have to use the TCP/IP and shared memory. You can implement some plugins and provide just the transport layer that the DDS can work over.
Is the multicast required? So can you run it over internet?
You can, as I mentioned, if you have the things connected on the same network, you can also define on the Discord. The QoS, I just mentioned some options, but there are more. You can, for example, skip multicast at all and say, I know your address. I don't want to spend time transmitting the multicast announcement to everybody. And then it's also possible to do using the configuration of the QoS. What I mentioned here is just a little piece of the QoS configuration that, in my opinion, is the core of the DDS, because it helps a lot to reduce the amount of code that you need to make it work. Welcome.
Earlier you described the concept of domains.
Mm-hmm.
Is it also possible that one device is part of two domains and sending both domains, or is it still two part of one domain?
You can have two domains, but in case the one publisher and subscriber, it belongs just to one domain. So, for example, if you want to send the data for two domains, you have to create two publishers in different domains.
So you run two clients on the same device.
You can have one application, for example, creating two. I mean, it's not, you don't need two applications. You can have the same applications, two publishers, each one of them transmitting in a separated domain.
Which is the overhead then, right?
Yes. But based on the concept that you define, for example, you attach the subscriber and the publisher in a domain, it's quite... Actually, I would take a look in the documentation if they improved it in the last, but as soon as I know, no.
I assume the data are sent as packets,
Yes.
so are they following the self-driving protocol?
It's using, for example, when you don't customize the data, you are transmitting over UDP. So, and all the things related, for example, if you have a huge data, all the segmentation also will be over the DDS or the UDP, TCP/IP, MTU configuration that you have in your system, and it will be reassembled by TCP/IP stack of the computer. Okay.
So, Claudio, back again. Maybe the simple questions. You'll stay, I'm sure.
Mhm.
Give Claudio a quick go. Yes, let's. Kan Claudio get set up on the projector? What you want to do with Rick? Or if you take what you want, you can subgroups or company. It's all for you. We'll get close up and then we'll keep going. Yeah.
Thank you.
Take a bit. Take some food. Yeah.
Thank you.
Just be careful what you say because you're online still. So, plug yourself in.
Mm-hmm.
And then I think what will happen is it will not recognize the screen again. So if you just dump, oh no, it's fine. Remember.
Let's give a few minutes.
Yeah.
Yep.
Cool. No, thank you. I'm fine.
not this one.
Okay, well, thanks a lot for being here still. So over the next minutes, I'm gonna talk to you a little bit about a very nice experience we had recently about hardening the Bluetooth stack for an IoT embedded Android system. So this presentation is basically going to be about three things. It's going to be about IoT, about embedded, and security. So this is pretty much which point I'm going to touch briefly in this presentation. So I'll tell you a little bit about us and then what systems hardening is in this context. Then what was our system? What were the client's requirements? And what was our solution? And what we learned out of this very nice experience. And then, of course, we'll have some time together to exchange question and answer. Okay? So I'll try as much as possible to make it comprehensible, because usually as soon as it comes to talking about security, people get, let me say, stuck too much in details, and sometimes might seem a little bit obscure. But actually, if you go straight to the core of the topic, you realize that it's very easy to grasp and to understand. So let me tell you a little bit about myself. My name is Claudio Pisanello. Like Thiago, I work in the embedded team of Concept Reply. I'm trained in electronics and communication engineering, and I can say I'm a kind of a jack of all trades, because over this 12 years I've touched pretty much all topics of IT industry, so QA, test automation, DevOps, embedded development, and recently I've moved on to project management. But nevertheless, I still enjoy coding from time to time, so I'm still there. Yeah, fun fact, as you probably can expect from a firmware developer, I'm a Linux and command line junkie. Yeah. So, and then what about us as a team, as a company? So, as Thiago briefly mentioned minutes ago, our core business as a Concept Reply is to offer end-to-end IoT solutions across a wide range of industries. And the team I'm proud to be part of is focused on the embedded part. What does really means? Actually focusing on designing, implementing, and verifying the solution for the thing part of the Internet of Things, okay? So we are focused on the low-level stuff, as you can see in this buzzword cloud. So we, as you can see, we specialize on a wide range of technical topics. So we work on several operating systems. So we work both on operating systems environment, and we also do bare metal programming. So we work on Linux, Android, on real-time operating systems, and so on. We provide expertise on a variety of tech stack like Bluetooth, SPI, CAN, especially which was pretty useful and used in automotive sector. Then Lean, I2C, and what we do with all this knowledge is providing a concrete actual solution for our customers in terms of protocols, device drivers, application software integration, and firmware over-the-air update, which is, as you can imagine, this last one particularly demanded topic in this area and the business of IoT. Yeah. So this is basically what we do every day here. So let's start with a simple definition, and probably most of you already know what systems hardening mean, but let's try to at least get all of us on the same page on this basic concept. What system hardening mean, actually in the context, of course, of software, is reduce the vulnerability of the system itself, which might be composed by applications, system, infrastructure, you name it. Okay, what you do, the way you reduce this vulnerability is to reduce the so-called attack surface. So you try as early as possible, already in the design phase, ideally, to be minimalist, to reduce the attack surface. Okay, so this is what hardening is, and in this presentation, I'm gonna show you something that we did in this regard. So we were asked by a customer to provide this solution for hardening an already existing system. Okay, and why this? Of course, this is something that you can apply conceptually in all across the IoT landscape. You know, when it comes to IoT, it's pretty obvious that security comes first. And in some industry, for example, aerospace, which Thiago touched before, on automotive, lack of security imply almost immediately lack of safety. And this, of course, is something that our customer must avoid at all costs. And we, as IoT specialists, help our customer to achieve this goal. Okay? So there are a lot of successful hardware systems out there based on a wide range of operating systems. So I just put here a few ones which I consider quite representative of this landscape, so to say. So Alpine Linux is very nice, lightweight, and by the way, used a lot in together with Docker and containerization technology. Then we got OpenBSD and Graphene OS for Android. And there's a lot of lot of other systems, but as I said, these are those who, which I find most representative. Okay, so let's jump right into our specific story. So what happened? So we had, as I said, an existing system which at some point of time required an upgrade of the hardware. And as you already can think, a hardware upgrade means inevitably also software upgrade. Okay, so there is, when it comes to this, there is always a massive refactoring at all levels of the entire system. Now, essentially, when you think about IoT system, what is an IoT system? It's basically a constellation of things. Okay, this is why probably it's called Internet of Things. Then you have some connectivity capability, let's call it this way. So you have usually a connection over mobile network. And then you got some services running all the time in the backend part, collecting data. And you can imagine that the purpose of this would be, to build up some data analytics value added. Okay, so this is pretty much what a typical IoT system is. Each and every part might be small or big, easy or complex, but this is pretty much the structure that we have. Okay, now in this specific specific example of ours, we as embedded team were engaged by the customer to restructure, to refactor the embedded part. Okay, now the embedded part of that system was made up mainly by 3 controllers. Of course, this is a simplified representation to make it for the sake of understanding. Let's put it this way. Okay, and you can see I just put some names: Alice, Bob, and Charlie, which, by the way, if you are accustomed with security topics, these are usually the names that are used in the literature. Okay, and in this embedded system, as you can see in this diagram, there were several hardware protocols involved. So there you can already see, let's say, some complexity. Okay, so we had between Alice and Charlie Ethernet over SPI. We had between Alice and Bob Bluetooth channel, and between Bob and Charlie we had LIN communication. So this means 3 different protocols, 3 different bit rates, and 3 different way to, let's say, on the transceivers to process the information and correct it if possible. So error detection and so on. Okay. Now, with this, let's say the core of this new requirement was implied that Bob had to be completely replaced, and I mean hardware and software. Okay, and Bob had from now on to behave as an internet gateway for Alice and Charlie. That means that Alice and Charlie had to continue to communicate uplink and downlink with the backend service, but passing through Bob, controller B, which in turn is connected to the mobile network with by means of a 4G transceiver. Okay. Now, the main, let me say, change compared to the previous setup of the system was the introduction of the Bluetooth channel between Alice and Bob. And this posed a significant amount of challenge from security perspective. And that's where the customer engaged us and looked for advice on the over the security implication. Okay, so let's try to think about to have a high-level view about all the possible challenges that this massive upgrade entailed for the system. Okay, so first of all, we had to deal with a legacy software, and if you are a developer or if you have worked as a developer in the past, you know that whenever you work with a legacy software, most of the time you have to deal with something which is big, ugly, very poorly documented, and so that means that you find yourself doing a lot of, so to say, reverse engineering. Okay, this is something which unfortunately you cannot avoid, is out of your control. Okay, so this is the first challenge. The second is power consumption. So we are dealing with embedded device, and this by definition means that you have the resources, the hardware resources are very constrained, and if you change the hardware setup, you must be very careful and make sure that the system has enough power to run and provide all the service to the end user all the time. Otherwise, you have service interruption, you have an impact directly on your customer business. And this is something you would like to avoid at all costs. Now, what is another challenge? Photo updates. In our case, this big, massive refactoring of the system implied that we had to change significantly the core logic of the firmware over-the-air update mechanism. Now, this is, let me tell you, this is a big deal, especially when you have, let's say, in production, you have a lot of those things which I highlighted in red in the previous slide. This is exactly the point of firmware over-the-air update. So you as a service provider, you want to make sure that you can save on your costs of the business by basically avoiding as much as possible to send let me say, deploy manual intervention, so to send physically technicians to go there and repair the system. This is what you want to avoid. This is why photo update is absolutely critical for any IoT system of a decent size. Okay, and then also it meant for us that we had to handle a whole new lot of edge cases, and that means reevaluate completely the quality assurance part. So it had to be, let's say, the coverage had to be extended, so we had to be very careful about this, and we had to make sure to cover all these new cases. But in terms of security, all these 3 points were nothing compared to the last one. And here were the real, let me say, challenge from security perspective lies. So Bluetooth as a communication channel, let me tell you, is not something really it probably is not the first on the list you would think of protocols that you would rely on for, safe communication. There is no even need to explain why. Everybody knows that. Okay, so it's unstable. It's definitely much less safe. There's also a lot of electromagnetic compatibility testing to be taken into account. And here's what you see in the black font in the bottom. Pairing widens the attack surface. That's where we, as Concept Reply, as embedded team, had to focus our attention on. Now, why is this a challenge? Why is this something to be taken care of very, very carefully? it's something definitely challenging, especially if you sum up all this observation. But we have the right expertise to deal with these challenges, and we were very happy to provide our customer our solution. Now, as I said, the Bluetooth by itself as a communication channel is not nice in terms of reliability. Why Bluetooth pairing is bad in terms of security? Because if we use the default pairing, and by default I mean take how you pair your smartphone or your tablet or your laptop with any Bluetooth device, this pretty much the mechanism is the same. So usually when you have two devices and you want to connect them over Bluetooth, you need first to do the pairing. Pairing basically means making Alice and Bob make sure that they can trust themselves, each other, okay? And then only after that, you jump on to the, let's say, the second step, which is channel encryption. And then only at the end, you start actually sending and receiving the real juice, let's say the real information, the real data, the payload, okay? Now, usually, this is, let me tell you, for those of you, especially who work in development on a continuous basis, this is pretty much the same concept that SSH is actually based on. So you always have this. So we are talking about, in technical terms, is called a hybrid crypto system. So where you have first the authentication phase based on asymmetric encryption algorithm, and then the channel encryption itself, which is carried out by means of a symmetric encryption algorithm. Now, and this is let's say the purpose of pairing itself. So the first part, the authentication, is to generate what we used to call the session key, which is used for the channel encryption. Okay, so as you can see here, there are a lot of steps. Now, here comes the question, why is this standard way bad in terms of security? Because Bob must be in discovery mode. And this is what you have whenever you want to pair your device over Bluetooth with another device. For example, your latest and fancy headset, okay? You must put the device in discovery mode, and that means risk of man-in-the-middle attack, okay? This is exactly what we want to avoid. Now, when we took, let's say when we were aware of this challenge, we of course started thinking about alternative, more secure alternative for to provide our customer. And so, first of all, we started discussing and say, yeah, you know, we should try to find a way to generate the session key without passing through the Bluetooth channel. Because if you do this, if you rely on the Bluetooth channel for transmitting the session key, again, it's a surface attack. We want to avoid this, you know. So, as a consequence of this assumption, we started thinking, okay, we should ideally have someone else who, beyond Alice and Bob, who generate the session key and then propagate and send it to Alice and Bob. And then after we thought about this, we took back, let's say, the big picture of the system and say, okay, wait a minute. Why don't we ask Charlie? So there's the third controller, which you've seen in a few slides earlier. Okay, so this is what we thought. Okay, as soon as the embedded module gets powered up, Charlie creates the session key by means of his dedicated set of security algorithms and libraries, and then propagates this session key, which of course must be exactly the same one, to Alice and Bob. And at that point, Alice and Bob, they can jump straight to the symmetric encryption. So by doing so, you delegate the first step, authentication, to Charlie, and leave Alice and Bob deal with symmetric encryption and, of course, payload exchange on top of this encrypted channel. Okay? Now, this is a technique which is in security known as encryption key injection. So if you're interested in this topic, you can Google it up, and you will find a lot of nice explanation and details. Okay. So yeah, so far I just talked about ideas, proposals, suggestions, but then we know as developers that we have to turn ideas into concrete solution and solutions that work. That's our business, okay? So of course, as a developer, your next question is, okay, that's fancy. How you're gonna make this a reality? Okay, how you're gonna implement this? Okay, now in our case, this was definitely a work in a team. So it was a real big teamwork. I was definitely not the only one. So also take the chance to say thanks to my colleagues. We made definitely a great job on at working on this. And in my specific case, I was focused on the refactoring part of the what I let's say indicated earlier as Alice. Okay, and Alice in this specific case was an headless Android-based embedded system. Okay, so it's basically, you can imagine, like has pretty much the same hardware capability of a regular smartphone. Okay, so an ARM platform, just without the display. So that's probably why they call it headless. Okay, and so for the rest of the presentation, I would focus more on let's say my part, but always keep in mind that this was just a part of the whole thing. And so we worked a lot as a team to achieve this. Okay, so here I put what you can find available on the internet. This is a classic stack of a vanilla Android system. Okay, so you have the system, the application. So, for example, the calendar, the camera, and so on. And then you have Java API framework. You have the middleware, and then as you go down, you find on the way the hardware abstraction layer, and then the customized Linux kernel, and then the power management, of course. Okay, so for me, the challenge that this new requirement posed was that I had to really do full stack development. I had to rework the whole system from application level down all the way. So this probably, so this is to give you the idea of how, let's say, how complex the making a system more secure actually means. You know, the fact is there are a lot of companies nowadays that want to gain their share in the IoT market, and to do so, there are a lot of companies who pay lip service to security and say, yeah, we provide a secure system, you can trust them, and so on and so on. But I am pretty convinced that very few people really grasp what it actually means to make an IoT system secure. And this is just a part of the rework that we had to do in our own specific case. And that you can already see that it's a lot, okay? But as I said, we at Concept Reply have the expertise to face this kind of challenge, and we were happy to do so, okay? So here is, let's say, a view of the same system, more focused on the Bluetooth part, because this is actually what we wanted to focus on. So what I had to do as part of this work was to code in 3 different languages, Java, C++, and C, and make all this thing work together, okay? So of course you start from, you know, the application framework, which is coded in Java. Then you have to make it work with the Bluetooth process part coded in C, and then you have to rework at lower level this part, so the hardware abstraction layer and the Bluetooth stack, which is coded in C. Okay. Here is more, even more detailed picture if you are particularly interested at the Bluetooth as a technology, as a topic. These were the specific blocks that I had to rework. In our own specific case, what we wanted was to use Bluetooth as a way to exchange payload for internet connection. So what we had to work on was actually PAN service. So PAN service, what it is, at the end is if you want to use your smartphone as a hotspot so that you can connect from your laptop to internet using your smartphone over Bluetooth, PAN service is what is going to be used, okay? Which was exactly our case. Okay, so I had to work on the PAN service, the profile, the adapter service, the manager service, and then all the way down the stack. Okay, so this was more a detailed view. Okay, and but then this posed, let me say, an additional challenge. As some of you might know about Android system, every application, every little block of the system is, let me say, segregated from the rest. That means that every single block runs on a specific dedicated process. But in the end, if you need to do full stack rework, you have to understand how to make this all different components talk on different, running on different processes and different threads. And that's where, of course, inter-process communication comes into play. Now, how do you handle IPC and an Android system? Well, Android provides a nice, let me say, facility for doing so. You basically, as a developer, can simply focus on defining the interface. So what kind of data you need to exchange from one level of the stack to another. And then when you compile the whole thing, so when you rebuild your system, and Android, or more precisely Android Studio as a IDE, will generate all the let's say the glue classes, which here you can find mentioned as a stub and proxy classes, which do the hard work for you, because whenever you do inter-process communication, you cannot simply exchange object as they are. You have first to translate this, the format. You have to convert the format of this objects into primitives, and this is really hard work. But luckily, Android can do this for us. So as I said, you just need to focus on defining the interface with AIDL, so Android Interface Definition Language. Okay, so this is what I had to take into account for our solution. And yeah, let me just spend some words about what we actually learned from this. Okay, well, first of all, yeah, you might be wondering, okay, so you had this nice experience. How did this end up? Well, I am happy to say that nowadays the system is in production since already some time. It's been used by thousands of people across the world. So we have a very happy customer, a very happy end user. So basically, this hardware upgrade did not affect the bottom line and the customer experience one bit. And this is something we are definitely proud of. Okay. Now, if we think about what we learned a little bit on the technical part. Okay, one thing that we learned, well, we already knew somehow, but we found out that actually power management is always something that you have to keep in mind. You have to spend a lot of effort to tune up a lot of parameters, especially when it comes to timeouts. It needs to be designed very carefully. And second point I reported here is a bit more a fun fact, but not so much. So, as I explained minutes ago, symmetric encryption means that you have two entities encrypting the channel using the same session key. If these two entities have session keys which are slightly different, then the channel encryption will not work, and these two entities cannot talk to each other. Well, they can talk, but they will not understand each other at all. Okay, so you cannot transfer payload. Okay. Now, in this case, this is also something which Thiago briefly mentioned in his very nice presentation. Indianness is something that you have as an embedded developer to take into account when you have a big system made up by several hardwares, made up by several platforms. Okay, Indianness is treated differently in different platforms, so you might have different components of the hardware system, which are little endian, other big endian, and you have to be to take care of this. Okay, for the exactly for the reason which I have explained 1 minute ago. If you might basically Charlie might generate the one session key only and propagate it correctly to Alice and Bob. But if Alice works on a little endian and Bob on big endian, then what you have is basically they try to encrypt the channel using swapped session keys. So communication will not work. So this is something that we had to find the hard way in our case. And yeah, we uh, we made up solution for this, and it worked wonderfully. Okay. Another last point, which I think is worth mentioning, is whenever you have to rework a system and touch several programming languages, especially when it comes to low level, you have to be very careful about all the libraries and utilities concerning with regards to byte arrays manipulation. Every language handles this in a different way. So whenever you have to put some glue code between those languages, you have to make sure that the propagation of the information across all these different languages is not affected. Because at the end of the day, what you want is that the information that is present at the application level goes unaffected right into the memory of the Bluetooth adapter in our case. You have to be very, very careful. Okay, so this was the end. Thank you for your time. Thanks for joining. Hope you'll find it interesting. Yeah. So, thank you. Yeah. So, any questions? Yeah.
Why was it not possible to use your channel over C to just communicate payload over that channel? Why did you need the Bluetooth between Alice and Bob?
Let me just go back to the so that we talk with yeah. So basically, we didn't choose Bluetooth as a channel because, to speak frankly, if we had the possibility to choose, we would have chosen Ethernet over SPI, for example. It's much more would have made much more sense. So the short answer is it was something out of our control. So we had to take it as a requirement. Okay. So the reason for this requirement, as you can imagine, goes a little bit outside the scope of this discussion. But as I said, we had to take it as a requirement. And then right after that, when we got this, let's say, blueprint from the customer, what we immediately thought was, oh, so you basically want us to use Bluetooth. Okay, that's where we have to be very careful, And this is basically what triggered the whole thing. Okay. Yeah. Any other questions? Yeah.
Yeah, another question. I think you were able to exchange this key over Charlie. Why couldn't we use just a regular Bluetooth connection and don't send the data encrypted with that key? So a man in the middle couldn't do anything with the data.
So would you mind to reformulate so that I make sure that I understand your question?
You had Charlie being able to send a key to both Alice and Bob, which you used to remind the Bluetooth and everything. But why couldn't you use just a regular Bluetooth connection with where there is a risk of some people jumping in and stuff like that, but just encrypting the data from both sides of the key, so even if there would be someone jumping in the middle, they couldn't do anything with the data because it was encrypted with the key you had all along at the beginning.
I think I understood what your point is. Let me. So there is one thing you need to take into account. First of all, we're talking about hardware and hardware system, which is expected to be frequently powered off and on several times. For security reasons, whenever this happens, you want to make sure that at every power life cycle, the key is different. So basically, you cannot thinking about hard coding, so to say, the session key and Alice and Bob and be done with it.
But hardcoding is like just using a regular Bluetooth session, which is insecure by itself, but then using Charlie to give both A and B a key over which they can encrypt the data, and then send the encrypted data over the unsecure line.
But this is exactly what we did. So Charlie's task was to generate the session key, send it to Alice, send it to Bob, and then leave Alice and Bob do the channel encryption by themselves. Yeah, so this is actually what we did. I hope this was more clear now. Yeah?
Very big questions over here. So, in a version of Bluetooth, to have a version of Bluetooth, how does it affect
Oh, this nice questions. I must admit, it's definitely something that you need to take into account, and we actually had. So I remember the talk that I had, that I was engaged with my colleague responsible for the Bob controller, and yeah, we had to consider this detail, but absolutely vital. So of course you need always to understand which version of which Bluetooth stack are implemented on Alice and Bob, which version and which services they actually support, and also specifically, more specifically about PAN service, which roles. So because there might be some controller who are designed to act as client, other as hotspot. So yeah, this is something we had to take care of. And then of course you might jump to implication like, okay, what happens if next year we got a new version of the Bluetooth protocol, or what happens if Android decide to replace the Bluetooth stack altogether? And this is actually what happened years ago, because now at the moment Android uses Blue Droid, but in the past a different Bluetooth stack was used. So the short answer is, if that happens, yeah, that's painful. So that's something that will require a new rework, definitely. Yeah. Yeah.
Any questions?
Yeah.
If I understood correctly, can we call Charlie an authenticator?
In a way, yes.
Okay, so in this example, it is connected via Ethernet to others. But I think you gave an example of a headset connected to via Bluetooth to a phone.
Mm-hmm.
So in this example, I would have to have the authenticator in between the headset and the phone. Is it like a separate piece of hardware or device, or is it?
Yeah. Okay. Let me try to get it for you across. So let's try to associate this image with something that we are very familiar with. So the classic smartphone to Bluetooth headset connection. Okay. So if you apply that familiar image to this system, basically Alice is your smartphone, and Bob is your Bluetooth headset. Okay. So what happens usually in that familiar scenario is that the authentication is handled by Alice and Bob over this Bluetooth channel. So these two guys, so the smartphone and the Bluetooth headset, cover the whole process: authentication, encryption, and payload transmission. Okay. Now, your intuition was actually right. So having Charlie means having a separate entity, hardware and software entity outside of this channel, but connected at the same time to both by means of a separate channel. Okay. Now, don't focus too much on my suggestion, to you, on what specific communication protocol we use here and here. The point that I would like to try to make is that here and here you have two communication channels which we know by design are safer than that, because this is wireless and these are wired. Okay, so we say, okay, let someone else act as an authenticator, as you correctly put it at the beginning of your question, and then use this existing channel that we know by design are safer to delegate the authentication to someone else and have exchange over Bluetooth only the encrypted payload. Yeah.
Not to be mean, I might say it's the last question for now, and if people want to talk afterwards, please feel free. I'll just say thank you to you, Claudio, and to
welcome.
Thiago, if he's still in the back somewhere. And thank you very much for coming. There's still plenty of food, there's plenty of beer. Please feel free to stay and talk. Next time, we have a different kind of meetup. We have two industry guys. So we have Marcus Young of Osram, and we have Christopher Ziegler from Actix.
Irgendwann war ich so im Berlin, but that's why I'm so that was what was on the boys was saying, so irgendwann reicht, dann ist es okay. Aber ich kann einfach Leute sind freiberuflich und jetzt ist also die waren die ersten. Es war wirklich okay. Das Budget ist jetzt abgeworfen und ja, freiberuflich sind die ersten. Achso, ja. Genau, ja. Aber das Ding ist, dass die Kunden haben, aber
machen und sie sagen normalerweise, ja, das ist so. Das ist ein bisschen anders.
Aber ihr fand ja auch nicht gleich. Normalerweise auch Analyse und dann.
Ja, also,
Was ist euer Rat?
ja, es gibt auch eine Schwesterfirma, Data. Ja, der Name ist ganz gut. Das war Irland. Reply hat Irland gekauft.
Wer hat die gekauft?
Irland, also Reply hat Irland.
Also, das ist das Data.
Ja, also,
Data Reply, genau. Ihr seid was?
Concept.
Konzept.
Ja, so, aber der Name ist ein bisschen überfällig, aber
Ja, und das ist halt parallel.
so, die Struktur ist so, das ist der Italien.
Italien? Wie heißen die? Auch gut.
Ja, es ist halt, weißt du, die Webs ganz speziell, das ist eine Familienfirma. In Italien ist in Italien ist es wirklich so intensiv. Alle von diesen großen Firmen in Italien ist es wirklich ganz gut. So wie das Joke. Ja, so, aber wir versuchen ganz langsam den Markt zu isolieren, weil wir verkauft haben, also in Deutschland. Ja, aber es ist schwer zu sagen, weil sie machen immer neue Firmen und neue Bereiche und ja, sie kaufen noch so Consisto.
Habt ihr gekauft?
Ja.
Nein! Nein!
Jetzt kommst du
So
gleich.
ein Consist.
Ja, genau, ja, es hat Consisto gekauft.
Ja.
Schottland. Ja, das
Ja, Chef.
normalerweise gehen sie. Ich kann es verstehen, weil irgendwann ist die Kontrolle weg und das ist schwer. Ich kann auch einfach das selber kaufen. Sie haben versucht, da zu bleiben und es geht wirklich nicht. Irgendwie dieses. Ja, das Büro ist jetzt gut bleiben. Sondern diese Replacement ist nur dann ist es Firmen, sie gehen ganz gut. Die Gruppe sagt, okay, sie kommt und es sind ganz viele und durchschnittlich normalerweise ist das vielleicht ein Partner, so wie Google, ja, ist ja was für Google? Ja. Genau, ja, also eine Cloud. Also die ist noch da, aber sie haben gedacht, jetzt haben wir IBM oder Microsoft. Nein, Microsoft hat es war entweder Microsoft oder IBM. Also Microsoft oder IBM. Und die waren die großen Anbieter für die Cloud. Aber Microsoft hat es gewonnen, glaube ich jetzt. Ja, Durchfall ist es wirklich. Ja, genau.
Microsoft, Azure oder was?
Ja, Chile. So. Aber ja,
IBM Cloud
es ist noch da, aber naja, ist.
Ich glaube, man sitzt nicht auf der Website.
Ja, was gut daran ist, die Cloud-Seite durchbillig ist. Im Vergleich zu Amazon oder Microsoft ist es.
Amsterdam ist wirklich okay. Ja, also das ist auf jeden Fall halt nicht für IoT. Warte mal, noch was. 2 Jahre später, dann ja, dann kommt man schon vorbei und sagt, okay, du hast auch noch was. Directory. Ja, so ist es ganz einfach. Deutschland war wirklich Microsoft. Alles. Wirklich. Also, jede Firma hat Microsoft irgendwo. Also, zumindest ein groß. Also, es ist immer ein Active Directory Server oder ein Exchange Server irgendwo. Microsoft irgendwann kommt und sagt, oh, das ist eine. Ja, als die wir verletzen haben, die Frage ist noch da, ist okay.
Ja, wenn man davon beeinigen.
Ja, also es ist einfach aufzuverletzen. Aber das ist noch da irgendwie. Ich bin so sicher. Aber es ist einfach aufzuverletzen. Es kommt auch an, ja, manche sind besser. Hauptsächlich. Aber es ist irgendwo auch. Running to the back end and they connecting them and thing or that's you are so yeah, make sure. You want to try it? Okay, so it's more using than like services of like
Yeah, I mean, let's use that as a platform, and then on top of it, they create services tailored for customer needs. So it is what they do usually very rough. So it's they develop their own solutions, their coding, and then they integrate their implementation within those available frameworks.
Right, and then we have like many software developers or also like also people are like doing coding and how
Most of us are actually, but for them now, recently moved on to managing how they still from time to time, but actually coding. So developers. But yeah, most of us are coding.
okay, so it's the developer also doing like the current representation and talking to the customer, needs,
Yeah,
so we have also people for that, or at this like your role, like doing it.
Well, yes, what we do is we work usually with
Yeah.
What we do very often is to brainstorming customer whiteboard, grow stuff, and so that we really understand what the customer needs are, and so that we can immediately turn this into actual working code. This, as you can imagine, is opposed to the old-fashioned style or writing mumbled requirements that you actually have relationship with the
So they often have like some kind of like some kind of like product owner or like business analyst who's like writing the user stories and you know, like talk to the customer and the interface with the customer, check out the requirements.
Say basically all this techniques of agile that we use.
Yeah, so this is my question now. Is that are the developer doing that? Or do you have to set a road for the stuff? So you have like when you
We say that there is not really clear distinction. This also we say by design inside Agile was the idea is to get everybody interact with without bureaucratic or unnecessary hierarchy. So what you usually have is customer side examples that owner talking with pretty much development team. Yes, my team or some of the team who is for a variety of reasons more engaged in the communication part rather than the technical part. But this, as you can imagine, was pretty much things like games. You know, part of Jai itself is try to avoid as much as possible this pigeonholing of roles.
So you're like these are software engineers and do you also like somehow take solutions to build a program for the communication? Do you take also like some kind of asset entirely that can leverage in this project, or like doing a project work, you can go to the customer and all this stuff for it, then go to the next project and people should do the same stuff, like more related thing stuff that you wrote, just with your emotion ahead, or do you also try to somehow do like some like something asset-based consulting, you know that you build stuff and then try to use that stuff on another project? You know what I mean? Because
It's first is we need to consider is that how to apply to rules, non-disclosure, non-simply copy-paste the specific path course. What everybody experiences once you, as an engineer, master a specific technique, then it's saying likely that in the future products, the very same idea comes up as useful. That even even if the use case is different, so then yeah, you might implement in a different way, but at the end, also based on my experience, first really brings takes most of the time, and the effort is as a in the design phase, finding out the right technique, the right approach, and then from that everything else follows. Then might use a change of framework or language. But what I personally find the most important is figuring out what the right technique is from a conceptual perspective. And this is what we do.
I was working with design, and I found it feeling like doing like things, same thing often again in different environments, different time. I think like no, you could have built just one product and other product, like it's much more scalable than doing all the time the same project, and you can only scale with people. You know, like for example, you know, like 50 or 60 people, you like scale to like to make more revenue, you need more people. You know, like
No, sure.
and I mean, instead like more focus on building product for which because you see like on the market often like according to this or that, you could like scale and make more revenue at the same time by building the product and then focusing on integrating the product or enhancing the product based on additional stuff in the time. You know,
You know what? And just think about automated programming itself. It's amazing important to the data so it's no mystery that every software development child that trying to so it really depends also on the strategy of the business model. But usually now it's coming to my mind continuous integration usually what you see is the first step you currently not adopt this CICD as a philosophy, as an idea, and you explore it, master the knowledge and tools used, and then you start thinking my problem, how to meet the same structure. And the project, especially when you say that agile department is doing frequent releases, and this is something you only achieve in an effective way for the CICD system. You start thinking, okay, how will we scale it without having to hire 20, 30 more people, which is exactly what you were thinking about as well. And this applies also to pretty much for everything.
That thing with that, you not say you would build like a reply CICD, you know, like kind of product which you maintain, or yes, and then every product is in that tool. And this will accelerate the work and the process. Yeah, and the customer will be more satisfied. You can offer products at a lower cost because you don't have to make the effort every time. You know?
So this is what happens. You will usually what everybody does is try as much as possible to just focus on the highest level part. So what actually change on the product. You just say, okay, we have this framework that we use it as much as possible, which is let's say ideal, but the reality is as numbers might be very difficult. Also, especially considering legal
and then you wouldn't have to use it. I don't know, like, I sometimes think like compiling change this, especially when it comes to software development. I don't think that building like everything from scratch for each customer is like in software development. We'll see. This now with Corona. How often writing change? Are you always on the customer side only? Or do you?
Well, it's like the same is that usually, personally, I work here, then also PM myself, going practice with clients.
Therefore, visit for like a meeting or a workshop or something.
Yeah, this kind of things. And of course, yeah, so say 1 to 2 months ago, were more strict in this case. Now, in general, face-to-face interaction, on-site interaction is more allowed, but the situation is continuously changing. So,
Because before Corona, I was like 4 days a week in time, and not very nice with home.
yeah, Jason, it's not video, of course. I did quite much. So, honestly, I enjoy,
Yeah,
interacting with colleagues.
and I mean, I lived in Frankfurt, and 4 days a week I went to Munich.
Yeah, I was in that situation, yes.
Yeah, so that,
That is
it's
a
different
different
than going to
use case.
But that was my question, whether you do it as well, like whether you always like 4 days a week on customer side, wherever it is in Germany or
Usually it's not so much. So,
you work as well?
yeah.
Ah,
We have, I would say, 1 or 2 exceptions. So there's shopping or
yeah. Okay. So the Corona, yes or no, it's or before Corona?
yeah, mostly, yeah. Set up.
Yeah. So what are you doing?
I have a front-end back-end area. Industrial IoT.
Oh,
Machines, data from machines, or gateway and cloud.
so also in the factory, like shop floor, actually? Oh, nice. Also in that area.
Yeah.
With the Lord. I don't know, would you see that as competition, or are you more like, what would you see as a competition?
You mean in terms of company?
Yeah.
Yeah, I mean, it's companies very high platforms or specific IT platforms.
So you like, for example, you will see as competition, or?
No, because I mean, typically for us, we develop something bigger, and of course, it's kind of a competition among the customers. So then, for us, it's always
But you also do make project with together with I don't know, like PC or AWS or
Yes, so AWS and Azure, for example. DDC, we are providing together the platforms that we develop and our customers.
then you like microservice based.
Yeah, sometimes serverless. It started with more on AWS.
Yeah. Honestly, was really like
That's your background.
information system and addition here. And now it is more technical related to so for smart manufacturing team, so they are actually designing automotive or chemical community, and then they are checking how can we get data from the machine, what can we get data, also like architecture, conceptual like work, and then we have development teams, nearshore, and so I'm programming more JavaScript, Java, Go, but
not on the PC, on the machine.
Lilium, no, but we are.
It's a
Yeah.
Ja, das sind ja gerade so an der Grenze. Beim User eigentlich nicht, aber ich muss also schauen, wie die Dinge sind.
Ja. Als ich mal angeschaut hatte, die Idee bei Künstlichen Kepler,
Ja,
ja, von bestimmten 120 Protokolle, 1000 PHP so. Das ist ja immer so das Thema da, wo man halt
ja, genau. Also wir machen es auch so, dass wir dann zusammen.
Wie läuft das immer bei euch aus?
Der Software, ja,